Hi everyone, my name is Ilya and it gives me great pleasure to present the Fullerene Factory on behalf of our group for the 2025 LLM Hackathon in Materials and Chemistry. Functionalizing fullerenes is a super important and interesting question for applications in such as medicine and in energy as well. Understanding how these molecular materials and their functionalized derivatives interact with each other, for example, their self-assembly behavior or how they interact with molecules of, for example, biological interest in their environment are really important. But there are lots of bonds on which chemistry can happen on a fullerene, right? Take even just C60, which is one beautiful stable isomer. There are many places where you can attach functional groups. If you go to what we call a controlled reaction, just as a typical cycloaddition, then you can have up to 6 groups being added to a cage. If you go to an uncontrolled reaction, such as hydroxylation, you're getting dozens of groups which can go anywhere on any of those chemically identical sites. As you go to larger fullerenes, this problem only becomes even more of a problem, and so you end up with a design space which is thousands of isomers large. Being able to model all of these in a kind of high throughput way so that we can plug it into then other computational workflows such as DFT and molecular dynamics would be really, really exciting.
Hi everyone, my name is Auditro. Now I am going to describe the overall workflow of our developed package Fullerene Factory. When a user passes a query about adding any addend on a Fullerene structure in natural language, first the query is parsed by the queries parser agent under initialization group. Once the structures are downloaded, then the workflow enters into the conformer queue. Here the combined structures are generated and optimized to find the best one. Finally, the workflow enters into the post-processing queue where the structures are stored and the workflow outputs the energy details of the best structures like this. Now I will show one of the generated structure which can be optimized later on using DFT or something else.